Hello everyone, welcome back to Pseudocoder. This is chapter number 3 and today we are going to look at trees. So let's get started. Now, what are trees? Trees are non-linear data structures, okay? It is a hierarchical style structure where you can store data that will be very easy to search for and easy to read. Okay, so let's get started and see how does a tree look like. All right, so tree has various components. The first one is going to be node. So node is something that stores value. So this is say, one node and we can have multiple nodes inside a tree. So, just so I can draw like 3. Now, how will these nodes connect to each other? They are connected using edges. So this can be one edge, whereas this can be another edge. Okay, so this is a node. The value inside it, it's going to be data. So for example, suppose this is 10. So this is the value associated with it, value or the data. These are called edges. So this can be a edge. Okay, the first node of the tree is referred to the root of the tree. Okay, so this is actually going to be the root node of the tree. And you can have multiple nodes in here. So for example, you can have something like this, something like this. Okay, and you can have bunch of numbers in it. So I'm just adding random numbers here. Now the last nodes. So the nodes that are at the very bottom are called leaf nodes. Okay, so these all are gonna be leaf nodes. One last concept about the tree structure is gonna be, sometimes you get a question of what is the height of the tree. Now, what is the height? So for example, now this is the tree that we have. So this is level 1. This is gonna be level 2 and this is going to be level 3, and height is actually the levels that we have. And so here the height is going to be 3. So the height of this tree is going to be 3. Okay, so that is about the structure of the tree. Now let's see what are the types of trees. So we have 3 types. The first one is the binary tree, second is ternary, and third is N-ary tree. Okay, so first we are going to look at what is a binary tree. Now, binary tree, from the name it suggests by means 2. So binary tree is going to be a tree where it has 2 nodes. Okay, so for example, if you have something like this and you have 2 nodes. Okay, so here you can have 2 nodes, 2 nodes. So you have to take into account that each node and its associated child node. And yes, one more thing that I forgot to mention is this is called parent node and it has 2 child nodes, this one and this one. Now, if we move forward, we can see that this is another parent node that has 2 child nodes. So every parent will have 2, at the most 2 child nodes. So that is what makes it a binary tree. It can have 0, 1, but the maximum is 2. That is why I said at most 2. Okay, so that is a binary tree. Now, even in binary trees, we have 3 types. Okay, so the first type we have in binary tree is a full binary tree. Now, what is a full binary tree? A full binary tree is a tree where you can have either 0 nodes or 1 or 2 nodes. Sorry. So for example, here suppose I have this tree. Let me try. Yeah. So do you think this is a full binary tree? Let's check. Okay. So root node is 1. That is fine. Okay. It has 2 child nodes. Okay. We are good. Now let's look at this node. It has 2 child nodes. Okay. Fine. Now let's look at this node. It has no child node. Okay. We said either 2 or 0. Then let's look at this node. This has 0 nodes, 0 child nodes. Okay. Then this one is remaining. So let's look at this one. This has 0 child nodes. Okay. So this tree has either 0 or 2 child nodes. And that makes it a full binary tree. Okay. Now let's take another example. Say you have something like this. Now, if we look at this example, you can see that, okay, this has 2 child nodes. Okay, that works. Now let's go to this one. This particular parent node, it has only 1 child node. So, by looking at this, it has 1 child node. It doesn't have either 2 or 0. So this is not a full binary tree. Okay, I hope this is clear. Now let's move on to the second type of binary tree. So the second type of binary tree is a perfect binary tree. Now, what is a perfect binary tree? A perfect binary tree is a tree where each parent node has 2 children, and except the leaf nodes. Okay, otherwise the tree is never going to end. All right, so let's see an example of a perfect binary tree. Now perfect binary tree says that when you have a tree, so for example this tree, okay, so you see it has 2 nodes, 2 children nodes, that is correct. And it has all the leaf nodes. Okay, so the leaf nodes are ending at the same level. And that is why it is a perfect binary tree. Now, let's look at another example. Another example is something like, this. So let's look at this one. So here, say I have this parent. Okay, it has 2 child nodes. All right. Then this particular parent has 2 child nodes. Okay. This particular parent doesn't have any child nodes. Okay, it is a leaf node. We can maybe, ignore that. But then there comes one other condition, that all the leaf nodes should be on the same level. And here it is not the case. And that is why this is not a perfect binary tree. Okay. Um, so that is a perfect binary tree. Now we have a last type of binary tree, which is very, very similar to perfect binary tree. It's the complete binary tree. So let me create some space here. I don't know what happened. Okay, so what is a complete binary tree? A complete binary tree is a binary tree where every node has 2 child nodes, except the last leaf node. The last leaf node can be absent. Okay, so for example, say I have this tree. Here you can see that I have this particular node. Okay, this has 2 children. That works. Then let's look at this particular node. It has again 2 children. Okay, that's cool. And then we come to this node. It has 1 child. Okay. And then it doesn't have the other child. Okay, it's not here. So it is okay if you don't have if one of the leaf node is missing towards the end of a binary tree, and that is actually called a complete binary tree. Okay, so this is an example of a complete binary tree. Okay, so I hope it is making sense. um, so going back to the type of trees. Now, binary tree, so we discussed this. We have 3 types of trees: binary, ternary, n-ary. We are going to look at ternary now. Inside binary trees, we have 3 types of binary trees. We have perfect, complete, and what was the first one? Full. Yeah, full, perfect, and a complete binary tree. Now we are going to look at what are ternary trees. Now, ternary trees are the trees that can have at the most 3 children. Okay, so it is fairly easy to understand since if you understand what is a binary tree. So here you'll see that every parent node will have three children. At the most three children. That means the maximum is going to be three. It can have 0, 1, or 2, 3 children. Okay. So here, you can say that this can be one example of a ternary tree, which is going all the way to the right. Okay. So this is actually a ternary tree. There are no types of ternary trees, so that is just one. So this is a ternary tree. Ternary tree is a tree where you can have at the most three nodes. And then the last one that we are going to look at is going to be N-ary trees. Now we looked at having two nodes. We looked at having three nodes. Now what is N-ary trees? N-ary trees is you can have n number of nodes. Okay, so one example would be something like, you have this node and then you can have as many nodes as you want. And then inside each node, you can have as many nodes as you want. Okay, so this is an example of N-ary trees. Okay, now moving on, we have a topic of basic operations. Now, so suppose now you know how the tree looks like. Okay, and suppose you want to add a node to a existing binary tree. How would you do it? Not a binary tree, I mean essentially any tree. How would you do it? So suppose you have this tree right here. If I want to add a node, what I will do is there are certain steps that you have to follow. First, you have to create a new node. So for example, I'm just going to value these as ABC. Now suppose I want to append D, and I want to append D to the left of the tree. So what I will do is first I'm going to create a new node with D. Okay. And then I'm going to see where I want to place that D. Now we already decided that we want to place it somewhere here on the left side of B. So what then I will do is I will say that on B's left side, first create a node D and then add it to the left side of B. So here you can do something like this. So that's how you add a node to a binary tree. Now things can get a little bit complex as well. As in if you want to insert something in the middle or something, at the top. These are some operations that are performed on binary trees, but I think these are out of scope for this particular lecture. Uh, you know, I will probably release another lecture on it if you guys need an explanation of how to insert a node inside a binary tree. If you do, please let me know in the comments below and I will work on that and get that uploaded for you. Okay, so that is adding a node. The second and the most important part that you need to understand is that when you want to search for a particular node inside a tree, you cannot just, have a for loop and then just go through everything. Or there are some ways, there are three ways, and you can actually access data inside trees using only those three ways. And these are called traversal orders. Okay, so you can traverse a tree using three ways. The first one that we are going to look at is pre-order. Okay, so what does pre-order means? So you have to think of a tree having three components. Okay, the parent, the node on the left, and the node on the right. So let's draw it out. So here, let's say this is 10, and then we have something on the left, so 5, and then something on the right, say you have something called 15. Okay, so you have to think of this is actually your root. All right, and this is your left, whereas this is your right node. And why? Because this is towards the this particular 5 is to the left of the root, that's why it's the left, and 15 is on the right. Okay, set up pretty self-explanatory. It is on the right, so it is the right node. Now, what happens in pre-order? In pre-order, you actually process the root first. Okay, so it is gonna be root. Then you process the left node, so left, and in the end, you process the right node, so right. So this pre stands for the root is actually going to be processed first. Okay, so this is something that you have to remember. Pre-order is root, left, and right. And how I like to remember it is by drawing circles. That's what I learned in college, and that's how I go about it until this time. Okay, so this is root, and then left, and then right. So this is how I actually understand it. And this is how I keep it in my mind. I just draw circles and then understand, okay, pre-order is root, left, right. So this circle, okay? That is pre-order. Now let's talk about in order. And I think, I mean, you guys are really smart. You might already have figured it out. In order is going to be, suppose you have a tree. So we are going to take the same example, 5 and 15. First, before moving on to in order, I just want to write the output of this. So pre-order, first root, so 10, then left, so 5, and then right is gonna be 15. So 10, 5, and 15. Okay. For in order, it is going to be left, root, and then right. In order means root is in the middle, and that is why it is going to be left, root, and right. So we process left node first, then the root, and then in the end, right node. Okay, so how does it work? It goes from left, root, and then right. So this is the circle. So you go left, root, and right. So that is in order. And if you do that, what is your output? Output is left is 5. So 5. Then the root, which is 10. And then the right, which is 15. So you see how the output changes if you use a different traversal method. Previously, we got 10, 5, 15. Now we got 5, 10, 15. Now the last traversal method is the post order. And post order is gonna be root in the end. Okay, so suppose we have the same example. So we have left, right, and then root. Okay, so it is going to be left, right, and then root. So when you do that, what is your left? Left is 5. What is your right? Right is 15. And what is the root? Root is 10. So this is going to be your traversal. Okay. So you just have to, it is very simple. I'll give you a simple trick how to remember this is you just have to keep in mind first left, then right. Okay. And then based on which traversal method you want, you can just plug the root. So for example, here say I have left and I have right. Okay. It is pre-order. That means root is going to be processed first. So add it to the first step. Then you have in order. So you have left, you have right. Okay. In order means root will be in the middle. In means middle. Okay. So just add root to the middle. Okay. You see, simple. And then for post order, you write left and right. Now post order, post means later, in the end. So root is going to be processed in the end. So you write root. So you see, you can use this little trick to remember the traversal methods. That's what I do. And that has kept me going for almost, I think, 8 years now. So I hope this trick is useful to you as well. Now I want to take you to my IDE and show you in code what the node looks like, what is left pointer, what is right pointer, that all the theory that we have looked at. And we will also see the code for in order, pre-order, and post order. Okay, so let's move on to the IDE. Okay, So let's see what a node actually looks like. So it is going to be something like this. It is going to be a class of node, and inside it, this is just a initialize method. And here you can see that you have a left node, sorry, left pointer. So self dot left. And initially, that pointer is going to be pointing to none. None means null or nothing, because you will be setting those links later on when you are writing the algorithm. Okay, so this is actually the structure. So there is a left pointer that is pointing to none. There is another pointer which is right that is also pointing to none. So think of it as a tree. It's basically a node. It has left and right pointer, and we can choose if we want to keep those left and right pointers. And lastly, we have a value. Now value is something that you assign to the node. Remember how we had nodes 10, 5, 15? So this is the place where the value will be stored. Okay, so this is what a node looks like. Now let's see how can you create a node and initialize it. Okay, so it's all the way down here. So what you have to do is uh, basically add the name of the class, and then you pass it that value. And how do I know how that I have to pass the value is because if you look at the definition, you see that it is accepting value and then assigning it to the node's value. Okay, so all you do is you have node, and then you add inside the parentheses, you provide a value. Now this might go a little over your head, but do not worry, we are going to look into what are functions, what are methods, and how to call them, and it will be much clearer then. But I just wanted to give you an idea of what a node looks like in a tree, because if you are a software engineer and if you are doing some competitive coding, you are going to run into this very often. All the tree methods or all the tree algorithm problems ask you to mostly create nodes, or even in linked lists. So I just want to go through it, and if you do not understand, don't worry about it. We are going to cover everything in one of the upcoming lectures. Do not get nervous. And then I'm going to the next step here is going where I'm doing is root dot left. So I am pointing my left pointer of the current root to my node 5. Okay, and the root of right, I'm pointing it to 9. Now in our example, I had 10, 5, 15, so I'm going to keep the same numbers. Okay, so I have the root of 10. On the left I have 5, and then on the right I have 15. So that's how you do it. Okay, now let's quickly go through the pre-order, in-order, and post-order code. And I hope it is easy to understand, and I hope I'll be able to explain it to you. Okay, so what happens in pre-order is that this is just checking if the root is not empty. Then you first process the root. This is basically a list that I'm maintaining, and I'm adding all the values into this result, and just returning it in the end. So here, so that I can print everything in one line. Don't worry about this. So the main point here is that if you look at this pre-order traversal, you see that the root is going to be processed first because it's pre, and then the left node is getting processed. Later, the right node is getting processed. Now, this is something where I'm, calling the same method inside this method that is called recursion. Now, I'm not going to go through recursion in this chapter, but I do have a video on recursion that will be very useful if you are trying to learn pre-order, post-order, or if you are learning trees. I would say you should please check that video out. It has a very clear understanding of what recursion is, how to execute recursion, how to deal with recursion, and all that good stuff. I will include the link in the description below. Okay, so this is basically a recursion call to the same method, and we are processing basically left and then right. If you look at the in-order traversal, you can see that you first process the left node, then you process the root, and later you process the write node. So you can see the processing right here. If we look at the post-order traversal, you can see that we first process the left, then the right, and then the root. Now, post order was left, right, root. And that is what we see here, left, right, and root. Okay. I have a print statement where I am executing all these three methods together. Now, let me execute this and show you. Okay, root is not defined because I have selected it. Okay, I'm going to run that again. Okay. So here you can see that in pre-order, we have 10, 5, and 15, which is correct because 10 is the root. Now left is 5 and right is 15. Okay, so root, left, and right. Then in order is 5, 10, 15. So in order means left, root, and right. So left is 5, root 10, and right is 15. So this is the one. And then post order traversal is actually left, right, and root. So left is 5, right is 15, and root is 10. So this is the output. And this is the same thing that we saw in the notepad. And I have outputted the same thing using the code. Now, don't worry, the code is going to be on my GitHub and I'm going to specify the link in the description below. So you don't have to follow along. You can just access that file and you will have the code with you. The very last concept that we are going to look at today is the binary search tree, also known as BST. Now, if you are someone who is learning Python for competitive programming, this is gonna be your jewel, your diamond, because if you understand BST, then everything will look very easy to you. So BST is from the name binary, means that it has two children nodes. And what is the one condition inside the binary tree? There is just one condition. Okay. It is that all the nodes to the left of the parent node should be less than the parent node, and all the nodes on the right should be greater than the parent node. Okay. So let's take an example. Here, say I have 10, and on the left say I have 15, and 5, and then here I have 15. So here let's validate this. So this is the root node. Okay, this is the parent. The nodes on the left, so here is 5. Is this less than the is 5 less than the root node? Yes. Okay, this is good. And then let's look at the right. Is the right node greater than the root node? Yes, 15 is greater than 10. Okay, then this is also fine, and then this is also fine. So this is a valid BST, binary search tree. Now let's take another example. Uh, let's say I have 8, I have 7. Let's take a little complex example. So I have something like this. I have, say, 9. Okay. So what will happen now is we are going to go to the parent. We are going to check, okay, we are at the root. We go to the left. We check, is the left node less than the parent node? Is 7 less than 8? Yes, it is. Okay, all right. This is passed. This is passed. Okay. Then we go to the right of the parent node. We check, is this greater than the parent? Is 10 greater than 8? Yes, it is. Okay, this is also green. This also is correct. Now we start exploring 7. We check what is on the left of 7. It is 9. Now all the nodes to the left of the node should be less than the parent node. So is 9 less than 7? No, it is not. Okay. So this is going to be flagged as wrong node. And so this is not a BST. Okay. So not BST. So this is actually the overall concept of binary search tree. Binary search trees are very, very famous in algorithm and data structures because they help you to organize data in a very systematic way, and it becomes very, very efficient to get that data from a binary tree. So that is one thing that is about the binary search tree. Now there are two ways of traversing the binary search tree. One is the depth first search and second is the breadth first search. Now, if you want to learn about breadth first search and depth first search, I already have a video on it. I will link the video in the description below. Check that out. That is going to give you a sample code that you can use in every other algorithm, and it will make your life so much easier. I literally use that code in every other BST or DFS problem that I have to solve, and it helps me so much. It saves so much time of mine, because then I can work on, the intrinsic details of what logic I have to handle, and then I don't have to worry about, oh, how do I do DFS? How do I do BFS? So you will get a base code for all those, for both of the algorithms. So please check that video out. It will be very helpful for you. I hope you liked this video. If you did, please give it a thumbs up and comment below. That really helps my channel. And also, if you would like to see similar videos like this, click on the subscribe button and you will be notified about all the uploads that I have. Also, needless to say, the code is going to be on my GitHub. All the links are going to be in the description below. If you have any questions, feel free to join my Discord channel, and feel free to have drop any suggestions that you have for me, or just any questions that you would like to ask. I release videos every week, so keep an eye out for that. And if you are someone who is learning Python for competitive programming, I do have a blind 75 and a algorithm data structure playlist, so feel free to check that out as well if you are someone who wants to practice as they learn, and that can be a very good opportunity. I hope you're enjoying my videos, and thank you so much for watching, and I will see you in the next one.